Hey, hello students. I want to go ahead and provide you with a sample problem on how to solve some of the problems that you've got on your homework. And the problem that we've got here is going to be a problem that looks at providing you some information, including the gram equivalent weight, which we call the GEW, and using that information to find the mass of a sample. So we've got a sample problem right here, and I'm going to go ahead and identify the important parts for us. The important parts here are the following. We know that we've got 200 grams of this equivalent weight. We also know that we have 18.5 milliliters being used of 0.100 molar sodium hydroxide. And what we want to know is that what is the mass of the sample in milligrams, and the sample here being a weak acid, when we engage in this kind of titration. And so the very first thing that we need to know is to determine how many moles we actually have of this particular problem here, or this particular sample. And the way we know this is because we know that the amount of acid is going to be equivalent to the amount of base in this particular problem. We need to make sure that we go ahead and solve it with that information. Since we don't know the volume of the titration, but we do know the equivalent weight, a good way to solve this problem is to solve how many moles we have on the right side using the base. So what we do is we're going to go ahead and take this amount here, the 18.5 milliliters, and we need to convert this to liters first. So that is done by taking 18.5 milliliters, and we're going to go ahead and convert this to liters. And the way we do that is we know that there are 1,000 milliliters in 1 liter. And when we do this math here, the milliliter units are going to cancel, and what that will give us with what we will result in is going to be liters, which is what we want. And this is the starting volume for us. And so what we get here when we do this calculation here, we're going to wind up getting the following number. We're going to get 0.0185 liters. And this is going to be liters of our sodium hydroxide, so we got to make sure we label that appropriately. NaOH. Now once we have the volume of our sodium hydroxide, or of our base, we need to find out how many moles we actually have. And remember, if we multiply a volume times a molarity, that will result in the number of moles that we've got, because essentially what we've got here is when we get volume is in liters. And when we multiply this times the molarity, notice that the molarity is going to be some number of moles of our solute divided by the volume of the solution, which is expressed in liters, and it's usually in 1 liters. If you look at this carefully here, our liter units will cancel, leaving us with the unit that we want being the moles. And so if we do this up top, if we actually engage in that, let me erase all of this here, but if we engage in that using the numbers that we've got up top here, we should arrive at the answer that we need in order for us to be successful at getting the number of moles. And so all we really need to do here is take this number that we've identified, 0.0185 liters, multiply that times the concentration, which is 0.100 molar, and so here moles per liter. The liters are going to cancel, leaving us the answer in moles, and the answer that we get here is 1.85 times 10 to the negative 3 moles, and this is going to be of sodium hydroxide. Now that we're here, the only thing that's left to do here is to find out how many grams this is going to be based on the equivalent weight that we're provided. In this case, we're provided 200 grams. Keep in mind that equivalent weight is essentially the mass associated with the protons in the acid, which is essentially kind of like how many grams you're going to have per every 1 mole of proton in solution, so 1 mole of the acid. And so in a sense, it kind of works like a molecular weight, but it's not really a molecular weight. It's a proportion between the mass of the protons in 1 mole of the solution of the acid. So therefore, what we do here is we take this moles, 1.85 times 10 to the negative 3, and this is going to be moles of NaOH. So let me erase that here for us. Of NaOH. And what we're going to do here is going to multiply this times 200 grams. And notice this is kind of like a grams per 1 mole of the acid. So 1 mole of the acid here. And when we multiply that, the moles of the acid cancels. That will leave us with a mass. And the mass that we wind up getting here is 0.36 0.37 grams. Notice that the problem is asking for us to provide the answer in milligrams up here at the top, and so all that needs to happen here is we take this answer, we multiply it times 1,000, and when we do that, the decimal point moves over to the right 3 spaces, essentially giving us the answer of 370 milligrams. And that would be your answer for this particular problem.